Example 3. Part A, list all the possible rational zeros. Here's our equation, polynomial equation. F of x is equal to 7x cubed minus 5x squared minus 63x plus 45. So we're going to list all the possible rational zeros. Now, as with the previous page, I talked about how just looking at the equation and being able to find the actual zeros. Okay, and the properties of roots of polynomial equations, it says if a polynomial equation is of degree n, such as this, 3, then counting multiple roots separately, the equation has n roots. So we have here, we're going to list all the possible rational zeros, but our highest degree tells us how many actual actual zeros we have. Then here we have if a plus bi is a root of polynomial equation with real coefficients when b is not equal to 0, then the imaginary number a minus bi is also a root. Imaginary roots, if they exist, occur in conjugate parts. Remember that word conjugate, meaning one is going to be positive, one is going to be negative. And let me read that last part. Imaginary roots, if they exist, occur in conjugate pairs, okay, plus or minus. So our possible rational zeros, we're going to list all the possible factors of 45, that's our constant term. So we have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45, and then we're going to list all the possible rational zeros of the leading coefficient, and that is 7. We have plus or minus 1, plus or minus 7. Okay, so let's divide everything by 1 to find our possible rational zeros. So we have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45, and then we're going to divide by 7 to find the other possible rational zeros. So we have plus or minus 1/7, plus or minus 3/7, keep going. We have plus or minus 5/7, plus or minus 9/7, plus or minus 15 over 7, and plus or minus 45/7. So these are all the possible rational zeros. Okay? Now, but here again, our degree tells us how many actual zeros we have. So to find the actual zeros, we're going to use the synthetic division. Beginning with 1, let's start with 1. So our coefficients are 7, -5, -63, and 45. Let's bring down the 7. 7 times 1 is 7. Add -5, we have 2. 2 times 1 is 2. Add -63, we have -61. And -61 times 1, we have -61. And when we add that to 45, we know that that's going to give us, I'm going to circle this because there is no remainder of 0. Okay? You can finish this part here. So 1 is not going to be the actual 0. Let's try -1. We have 7, -5, -63, and 45. Those are our coefficients. Let's bring down the 7 again. 7 times -1 is -7. -7 plus -5 is -12. -12 times -1, we have 12. 12 times -63, we have -51. -51 times -1, we have positive 51. You can finish that off again, but that still does not leave us with a 0 remainder. We want 0 remainder, okay? So we go down the line. Let's look at positive 3. So here we go. Again, 7, -5, -63, 45, Bring down the 7. 7 times 3, we have 21. Add negative 5 to that, we have 16. 16 times 3 is 48. Add negative 63 to that, we have negative 15. Negative 15 times 3 gives us negative 45. And we have now our 0 remainder. Therefore, right now, 3 is one of the actual zeros. Okay? And remember, going back to that factor theorem, okay, x plus 3, okay, and I'll go to page 80 just to look at this concept again, just to repeat it so that we all can understand this. Okay, it says if f of c is equal to 0, okay, so what this is saying here, if, this is the factor theorem on page 80 of our notes, if, or let, let's scratch it off, we have it, if f of 3 is equal to 0, then x plus 3 is a factor of f of 3. Okay, so we have one of the factors. We have x plus 3. Now we need to find the other factors. Okay, so therefore we're going to create a trinomial with coefficients of 7, 16, and negative 15. So here we go, x plus 3, here's our factor. Our other factors, 7x squared plus 16x minus 15. And we're going to set it equal to 0. Then we're going to set each factor equal to 0. We know x is equal to 3. That's one of our solutions, negative 3. Excuse me, let's go back because I think I did something wrong. This should be, while I'm saying this right now, this should be minus 3. So if you caught that, great. So minus 3. Let's change those. Therefore, x is 3. Okay? And then 7x squared plus 16x minus 15. If we can't solve this by factoring, solve this trinomial, this quadratic equation by factoring, then we will use the quadratic equation. But we can factor this. So factors of 7x squared, we have x and 7x. And factors of 15, we have 3 and 5, and then we have a plus sign with the 3 and a minus sign with the 5. So we're going to set each factor equal to 0 and solve. So our third actual 0 is negative 3, and then a second actual 0 is negative 3, and our third actual 0 is 5/7.